Okay, let's find the relative max and min of this function, which is g of x equals 3x to the 4 minus 12x squared plus 9. Like before, we just find the first derivative. For these polynomials, it's pretty easy. That'll be 12x cubed minus 24x, and the 9 just goes away. So, in order to find out relative max and min, we need to go ahead and set this equation equal to 0. When we do that, we get 0 is equal to 12x cubed minus 24x. And now we just solve this equation. Notice that we can factor off an x. Whoops. So I factor off my x and get 12x squared minus 24. All right. Okay, so now we can just solve that. So first off, that x out in front means that one of my values is x equals 0. And we also need to solve the equation 0 equals 12x squared minus 24. Okay, we can do that. Add 24 and divide by 2, and you'll get x squared equals 2. That's just adding the 24, divide by 12. We get x squared equals 2. Which means that x is equal to the positive or negative square root of 2. So I did that a little quick, but again, hopefully you can just solve that equation. So our three zeros are 0, positive, and negative root 2. So those are our candidates for maxes and mins. Let's start with x equals 0. So for 0, what I get is I need to pick 2 points close by. Now don't pick points further away than root 2 or this will be messed up. So the 2 points I'll pick are -1 and 1. And we'll just look to the left and to the right and see if it's falling or increasing. So I plug these, remember, plug these back into the original derivative, this g prime right here. That's the one we're plugging them into. If I plug in 1, I get 12 minus 24, which is -12. So we're decreasing at 1. If I plug in a -1, I get -1 cubed, which is -1, times 12 is -1, minus 24 times -1. Well, that'll end up being -12 plus 24, which is positive, and so positive 12, so we're increasing right there. So increasing to decreasing, 0 is a relative max, and if I plug 0 into the original function, I get a y value of 9, because of 0 minus 0 plus 9. So 0, 9 is a relative max. You can do the same thing for these square roots. The next value we'll check is x equals the square root of 2. So the two values I'll check for that are 1 and 3, because I know that square root of 2 is right in between those two values. In fact, if we wanted to, I suppose we could pick 1 and 2. Let's go ahead and do that, because then our numbers will be smaller. So we'll check 1 and 2. Now we already know from the previous one that at 1 we're falling. We're negative at 1, so we don't need to check that again. Let's go ahead and plug in 2. 2 times 2 times 2 is 8. And 8 times 12 on my calculator is 96. So we have 96 minus 48, because 2 times 24. So that's going to be positive. So we go from down to up, and so that's going to be a relative minimum. And if you plug in that value into the original equation, we should get the value square root of 2 and -3 is a relative minimum because we are falling and then increasing. Likewise, if you do the same thing, I'm not going to show it right now, but you could do the same thing for x equals negative square root of 2. And you could test the values -2 and -1 to see what happens. At -1, we were increasing, and I know that from before, our earlier check. If you were to plug in -2, you would see that the value is decreasing. And so again, that will be a relative min. I skipped a couple steps, but hopefully you see the idea of how to check them. These checks need to go into the first derivative, and if you want to find out the y value, you would just take the negative square root of 2 and plug it into the function, and when you do that, you should get -3. Okay, in the next video, we'll do another example.